The next panel here is low carbon aviation solutions. Is sky the limit? We're a short one panelist, so the last minute change. I think many of you have heard the joke from Peter Thiel that we asked for flying cars and all we got was 140 characters. Well, the CEO of Luftcar, who was scheduled to be here, has something akin to a flying car, so we were going to have that, but fear not, because our moderator and performing more of as a panelist here, Danielle McLean, who is the engineer and entrepreneur and is the forefront of hydrogen aviation. She's the founder and CEO of HYSKY Energy, which is a 501c3 nonprofit existing to promote hydrogen-based technologies. She's going to moderate our panel, and she can tell us about flying cars as well. And so she's going to have a discussion here with Monica Karamagi, who is the North American business leader at Shell for biofuels development. So let's welcome them onto the stage, Danielle and Monica.
Hey everybody, can you hear me? Awesome. So as Carrie said, I'm Danielle McLean. I'm the founder of HYSKY Society. We're a 501c3 advancing hydrogen aviation. It's my pleasure to be here with Monica Karamagi. I hope I said it right. Monica is a regional business development manager for the Shell low carbon fuels business based in Houston, Texas. She's worked for the last 25 plus years in various technical and commercial roles and now leads the advanced biofuels team. This team is scaling novel technologies to produce commercial quantities of low carbon sustainable aviation fuel from sustainable feedstocks. She has a master's degree in chemical engineering from Harvard University and a general management certificate from the University of Texas. So please welcome Monica. So Monica, I want to start off by asking you, what is sustainable aviation fuel?
Sure, let me do a mic check. Okay, first of all, a couple of clarifications, and lovely to see you all, and thank you very much for having me here. It's a pleasure to come and speak to you, having done my general management certificate here at University of Texas. What I left out of the bio was that my undergrad was at Texas A&M University. I don't know why I left that out, but worth mentioning. And also a small correction, my master's was at Howard University, which is frequently confused with Harvard, but is equally good. So happy to be here. And your question, what is sustainable aviation fuel? Maybe let's just first step back a bit and have a common understanding of the energy system, and then drill down into sustainable aviation fuel. So as we know, our energy system, we use energy to power transportation and industry as a fuel, and in buildings for lighting and heating and cooling. And that transportation system is 80% based on fossil fuels. And of that transportation system, in the transport segment, you then have aviation fuel, which is again jet fuel, as you know it, that's used to power airplanes. Sustainable aviation fuel, or SAF, is defined by the International Civil Aviation Organization, ICAO, as a fuel that is based on feedstock that are waste-based, and that a fuel that meets certain sustainability criteria. That sustainability criteria is usually the carbon intensity, so how much carbon emissions that fuel gives off relative to a baseline fuel like jet fuel, which is fossil-based. And typically we are looking, sustainable aviation fuels have carbon intensities that are at least 50% lower than a jet fuel, and so that would qualify a fuel to be a sustainable aviation fuel. So the feedstock that it's made from needs to be waste-based, and its overall carbon intensity based on a life cycle analysis calculation needs to be significantly lower than the baseline fossil fuel, jet fuel.
Oh, that's fantastic. Thank you so much for that background. I'm curious, how many people in the audience have heard of SAF or hydrogen-powered aviation? Awesome. How many of you know that there's a difference between hydrogen and SAF? Okay, about the same amount of people. Awesome. So, Monica, why does the aviation sector need to decarbonize?
Yeah, that's a really good question. Again, I talked about sort of the big three buckets of energy consumption in our energy system: buildings, industry, transportation. When you look at the transportation segment, actually, that segment contributes about 30% of the overall carbon emissions, at least looking at recent numbers, 2022 numbers. When you drill down within transportation, the aviation bit of it is only about 2% of the overall macro carbon footprint being emitted, but it's a difficult 2% to mitigate. So again, looking at transportation, giving 30% of the emissions, most of that, passenger cars, for example, has a solution, and that solution is believed to be electrification. And we can already see that happening, greatly so in Europe, and somewhat so in places like Austin and California and in the Northeast US, with more to come. So there's a firm belief that electrification will be the next wave to decarbonize the passenger car sector. You then have light duty, medium duty, and heavy duty trucks, and there are solutions there in terms of, again, electrification, in terms of biofuels, and also in terms of hydrogen. When you look at aviation, it is a difficult segment to decarbonize because, again, look at the size and the weight of an aircraft and the distance that it needs to carry to take us to all the exotic places that we like to go to. That is a lot of fuel. There's inherent safety risks. So let's just start there, because safety is number one with a very energy-dense fuel like hydrogen. There's significant technological and innovation challenges there to design a fuel that can actually safely transport human beings across long distances. There's a lot of strong initiatives so far to get hydrogen going in the aviation sector, but we see that as slightly further out, and I think you'll share more on that. But again, so the aviation sector, we don't have a handy solution. We believe that sustainable aviation fuel, which again, as I said, waste-derived fuels, are a neat transient solution to a more permanent solution, whether that solution is things like e-fuels, which are synthetic fuels, or things like hydrogen-fueled or hydrogen-powered engines. So yeah, aviation, really challenging from the size and weight of the aircraft, the cost to implement the transition, safety, number one, I should always mention that first. Quality control, how we just don't have the infrastructure set up in our aviation infrastructure to make sure that we have, hydrogen fueling facilities, regulations and the regulatory support with different governments to ensure that this hydrogen infrastructure is operated safely and fairly. So there is a bit of a journey to decarbonize the aviation sector, and biofuels appear to be the most immediate solution, so things like sustainable aviation fuel, with other things like e-fuels and hydrogen being longer-term solutions. But it is a difficult segment to decarbonize for those reasons.
I love it that you said transient. That's probably the perfect, I usually say intermediary, but I'm definitely gonna start saying transient. Because if you think about like cars, it's not that hard to put a bunch of batteries in a car and electrify it. I mean, look at Teslas and tons of other electric cars coming on. If we did that in aviation, there would be so many batteries. We have a different problem in aviation. We have to defy gravity, and batteries are really heavy. So yeah, it would just be this massive, literally massive mass that would, not allow the aircraft to take off. And then when we look at hydrogen, it's like, yeah, it's technically possible, but we don't have the infrastructure to support it. And so that's where SAF comes in, biofuels come in, that can kind of be that intermediary or transient fuel. I love it that you said that, and I agree with everything you said. That was beautifully said. Could you help us understand Shell's aviation projects and their sustainable aviation projects?
Sure. Yeah, my background, as she shared, as a chemical engineer, worked in mostly in the chemicals businesses in Shell, and then with the 2021 announced strategy to really power this transition or change in the energy system, I moved into this biofuel space of Shell. It's really energizing to be in a company that is thinking every day about how to move this transition along, recognizing that we are part of the problem, but we're also part of the solution, and in fact, we have to lead the solution. So that's just personal perspective. What is Shell doing? Shell is investing about $10 to $15 billion in the next few years running up to 2030, which is quite a material part of its capex in low carbon solutions. Then that's low carbon solutions in general, whether it's things like hydrogen or CCS or methane emissions reductions, etc. Let me then bring it home to what we're doing in the aviation sector, because that's the topic of the moment. We have invested in a technology called alcohol-to-jet technology via a company called LanzaJet. Remember, these are very nascent technologies and really difficult technologies to execute. What makes them difficult is the feedstocks themselves. So remember I said sustainable aviation fuel is defined as a fuel that comes from a waste feedstock. Because you want to have a low carbon footprint, you want to be reusing, recycling, that feast, starting from a waste is inherently a nice way to reduce your carbon footprint. Those wastes contain carbons and hydrogens that are very difficult to unlock and re-release to burn as fuel. They're either bound in biomass, and so you have to use high temperature to pyrolyze these wastes to then release the carbons and hydrogen. So there's technologies like alcohol-to-jet, which involves dehydrogenation of ethanol and then hydrogenation. It's a number of chemical processes. Looks almost like a mini refinery. But because you start from a feedstock that is a bio-based feedstock, corn ethanol or sugarcane ethanol, your net carbon footprint of the final fuel that you produce is lower than that of, let's say, a jet fuel from crude oil. You have about a 50% reduction in carbon intensity starting from the ethanol route, again, because ethanol comes from corn. So we're investing in that alcohol-to-jet technology, being fully aware that they are spill-on effects that you need to mitigate on things like potential land use change, so you don't want unintended consequences based on the types of feedstocks that you start with. And then being fully aware that there are no commercial prototypes yet. There is no scalable production at a refinery scale of these types of fuels. So LanzaJet, which we invested in, is just commissioning their first prototype in Surbiton, Georgia. And so Shell is an investor there with companies like IAG and Mitsui, British Airways and Suncor. So that's using corn ethanol as a feedstock or sugarcane ethanol as a feedstock. We've also invested in a project up in Canada with Enerchem, and that's a very different one that's taking trash and using the city of Montreal's trash as a feedstock, trying to get carbons and hydrogens out of that through gasification, again, a massive endeavor, many millions of dollars, to build that prototype facility that will take trash and make a fuel. In this case, we're making methanol, but there are paths to get from methanol to things like gasoline and jet fuel. Again, very nascent technology, very risky technology, and very early stage. High risk in terms of will you see a return on your investment. So I've talked about LanzaJet, and LanzaJet from corn ethanol and sugarcane ethanol. I've talked about Enerchem from trash. I think I'll pause there because those are some of the more public investments. My team had a portfolio of projects that we are constantly looking at the financial viability of the projects as well as the technical viability of the project. But just suffice it to say that because of the feedstocks that you're starting with, whether it's corn husks or corn stalks or sugarcane or trash, you are inherently one, you have the benefit of the low carbon intensity footprint of that feedstock, but then you also have the blessing/challenge of how do you get the carbons and hydrogens out of these feedstocks and recycle them back in the energy system. And that involves some very sophisticated chemistry. So we do have those commercial projects in play. We have a HEFA project in Europe, which is using fatty acids, using basically fats, oils, and greases, and recycling those, hydrogenating those in existing refineries to then produce a portion of the fuel as a sustainable aviation fuel, because it's coming from fats, oils, and greases. And then beyond that, I can't really share more because, again, very nascent, early stage technology, some of them still in lab stage, some of them still at prototype stage, working with the universities like yours to see what could actually become scalable.
That's fantastic. And, you know, I'll just touch on, I'm not with Shell, so I can say, there are a few hydrogen aviation companies that I think Shell was looking at, to say the least. And one of them is Zero Avia, another one is Universal Hydrogen. And a lot of people, you know, they tend to, especially in the aviation industry, there's sort of this idea that it's SAF versus hydrogen. But that's not the case. You know, at HYSKY, we very much believe in hydrogen aviation, but we also believe that SAF is a step to getting to hydrogen aviation, and that, you know, what you all are doing at Shell is critical to our success, and also that hydrogen can be a feedstock for SAF, and that could help kind of, you know, lower the cost for hydrogen. If we could, and I think you would agree, if, you know, airports could supply liquid hydrogen to aircraft right now, I think we would see every airline flying with hydrogen. It's really just a matter of that cost being, you know, $15 to $30 per kilogram is just not feasible from a cost perspective. But if we see SAFs come online, then we're going to see all of these other exciting things. But I will point out that aviation, aerospace in general has, and this is where I get excited, I'm our aerospace engineer background, we have been the catalyst to commercialize a lot of technology way before it was, you know, feasible for the general public. If you look at, you know, telecom, satellites, robotics, biomedical, I mean, you've seen all of these things come out of space and defense. And so that's where HYSKY kind of is, you know, we see what Monica, what you're doing at Shell, kind of coming from, you know, where we're at going forward, and then me sort of coming from the future and working our way back from aerospace, saying like, hopefully we'll kind of meet in the middle and then, you know, see this technology take off. And so I'm personally really excited about hydrogen. Do you guys look at, I know this isn't one of the questions that we had sort of talked about, but are you guys looking at hydrogen as a feedstock, and how does that, you know, kind of play into what you were talking about with the mini refineries sort of thing?
Yeah, no, this is a good question. I think many are aware, but probably worth recapping. There's different types of hydrogen. So the everyday hydrogen that you make from steam methane reforming, gray hydrogen. Then you've got blue hydrogen, where you would take that gray hydrogen and inject the carbon emissions into a carbon capture system, a carbon capture and sequestration system. That's termed as blue hydrogen. Or you could start with water as your feedstock and using electrolysis and hopefully definitely having renewable power, separate the H2 from the O and make hydrogen that way, and that's green hydrogen. So what is Shell doing? We're investing heavily in green hydrogen in Europe. So we have a Holland hydrogen project that has an FID to it and is currently under construction. It'll feed the burners at our refineries in the Rotterdam refinery complex and bring down the carbon intensity of the products coming off of that asset. So we firmly believe where you have ample and adequate renewable power, green hydrogen makes sense, and that is a 200 megawatt reactor that capacity of electricity that we'll be producing there. Nice. For aircraft, I think it's still early days. Our views on hydrogen are, again, still investigative. So we did invest in Zero Avia, or not invest, but we have an MOU and a collaboration initiative with Zero Avia to see if we can make aircraft with hydrogen-fueled engines. That's thought to be a longer-term play. Like I said, we know that biofuels are a drop-in solution. They can meet ASTM standards and enter into aircraft today. And in fact, that's already happening, so I'll touch on that a little bit. But we see hydrogen as further out, but definitely worth investigating, hence our collaboration. And then we really continue to focus on finding adequate renewable power, so investments in wind power in the Middle East, because without affordable renewable power, you really cannot make investable green hydrogen projects. And so there's a natural connection there that we're working on. So that's our view on hydrogen. Just also forgot to mention, as far as SAF, it's still very much a sliver of the jet fuel that's out there. But you may have flown in an aircraft that has SAF already, because you will now and then read press releases about airlines that have done test flights with SAF in it. It is, again, technically meeting an ASTM spec when it's approved, and so it is used by aircraft. It's blended with jet fuel, and you have over 25 airlines that have announced targets to blend X% of their fuel with SAF, by 2030, et cetera. So, every day there's announcements about airlines wanting to do SAF, and as SAF becomes more commercially available, you'll see more and more airlines touting their use of SAF. The challenge is, besides the technology challenge that I just explained, there's a follow-on cost challenge to the airline, because that sustainable aviation fuel is 2 to 4 times more expensive than the fossil fuel. And I think everybody knows how the airline industry is doing or not doing, and so they don't necessarily have the capacity to absorb this extra cost. And we as passengers haven't been quick to line up to pay for this extra cost either. So there is that challenge around cost that's making the uptake of SAF take longer. And so government mandates, actually not really mandates, that's more of a European approach, but more incentives. So in the US, there's the 2030 SAF challenge by the Biden government, encouraging airlines to use more SAF. Tax incentives, policy incentives. I think all those are catalysts that are needed to allow for more SAF uptake with the airlines. There are real challenges, but there are real examples of everyday SAF use as well, so we're very encouraged.
Yeah, there were a lot of good things in there, what you said, and you made me think of something that I forgot to talk about, which is SAF being a drop-in fuel. So, one of the things that's kind of like common, I guess, knowledge in the aviation industry is that hydrogen burns, there's no carbon in it, so there's no carbon emissions. SAF, there is some carbon emissions, but it's the way that you produce the fuel that makes it more sustainable. So, Monica, you mentioned that it was a drop-in fuel, meaning we can use these fuels today without having to change any infrastructure at the airport or on the aircraft itself. Hydrogen, not so much. I mean, you've got to have new ways of storing it. You've got to have these, cryogenic tanks if you're using liquid. You have to have high-pressure tanks if you're using gaseous. So it's much more challenging. You can't just make the switch overnight, go to DFW and say, hey, we want to come put hydrogen here. That would disrupt, the entire world if we tried to do something like that. So SAF is an answer that can, become more sustainable right now. But like you said, it's 2 to 3 times more expensive than fossil fuels or traditional jet fuel. But hydrogen is like 10 to 20 times more expensive, and that's assuming we have the infrastructure in place. So something that, HYSKY does as, a nonprofit that's advancing hydrogen aviation, we go to airports and we help them bring hydrogen into ground vehicles, forklifts, tugs, these sorts of things. So we can start putting that infrastructure in place slowly over time. Then as the cost of hydrogen comes down and as SAFs are coming more online, then we can start to sort of slowly implement this infrastructure in. And so let me check the time, because I will, oh, thank you. Okay, we've got 5 more minutes. But we want to do questions. Yeah. So could you talk about you sort of already touched on this, but some of the other challenges with widespread commercialization and how Shell plans to, I guess, see a return on the SAFs and the sustainable aviation fuel sector.
Sure, yeah. We talked about costs, so I'll just mention it again because it is probably right up there at the top, but I don't need to belabor it. There is an affordability challenge. Technology, I mentioned that briefly, but proving that you can generate ASTM quality sustainable aviation fuel at scale is difficult. And again, the innovation from universities, from labs, from small entrepreneurs is important, and we come in there and we try to scale that. But the right technology is definitely a challenge. Feedstocks, maybe I haven't talked enough about feedstocks because, like I mentioned, sustainable aviation fuel is fuel from waste feedstocks. But we do need to be careful about how we vet and source these feedstocks. For example, if you are going to gasify a forestry biomass, forestry waste biomass, with emphasis on the word waste, as a producer, you need to be 100% sure that that is forestry waste, that it is certified forestry waste, that there is an understood definition of forestry waste that is actually executed by a supplier, that is traceable, and that you are not inadvertently, picking off good forestry. That is never the intent. We don't want to be undoing the carbon sinks of the world. So that, the type of feedstock you select requires a lot of careful consideration to really understand beyond the math and the carbon intensity and the theoretical approach to the feedstock. What are the commercial risks? What are the execution risks as I approach this particular path? So forestry waste and the traceability of forestry waste as a feedstock, definitely challenges there. Waste-based feedstocks like trash, it sounds very exotic and sensible to take trash and somehow return it back to fuel, but there are execution challenges around sorting facilities and scalability. How will I get, to make this much fuel, you need this much trash. How will I scale it? Do I partner with sorting facilities in 100 cities around the US? Do I just target the Northeast corridor? So the execution challenges around some of these concepts are immense, as well as the societal optics around making sure that you really are able to trace and protect the environment in everything you do. Same thing with feedstocks like corn ethanol or sugarcane ethanol, just making sure that land use change is not a side effect that you inadvertently didn't take into account. So Shell is very careful about all of that. I think all producers would have to be very careful about all of that to go from beyond the theory into really being able to demonstrate the stewardship in the execution of that fuel. So we talked about cost, technology, feedstocks, incentives we talked about before, partnering with government and having the right policies in place to make sure that there is an incentive for the airlines to take up these fuels is key, because they also have shareholders and they also need to demonstrate a return. And so they will really need the right the right policies in place to allow them to take up these more expensive fuels. Yeah, I think I can stop there. The rest are practical things like regulations, ASTM regulations, infrastructure and logistics at airports. But with SAF, it's less of a challenge because it is handled like jet fuel. Testing, just to make sure that our standards indeed protect us from a safety point of view. So there is a big ecosystem of activity that goes with changing the type of fuel we have in our aircraft. But we welcome the challenge, and we certainly see significant progress today. So,
thank you. You made me. That was a perfect ending right at 11:30, and we will do Q&A. By the way, if you have one, I think there's a mic floating around somewhere. But I'm just curious, while we're waiting for the first brave person to ask a question, how many students are in here? Oh, that's awesome. So something that Monica said that we didn't talk about was optics. And, things are changing. I'll just say the word, I know you all have heard it, is greenwashing. And transparency is so important. I never thought I would find myself as an aerospace engineer. I never thought I would find myself in an environmental nonprofit, but it's very rewarding work. And if you're interested in energy and the things that she was kind of talking about, transparency, because hydrogen is the same thing. You have to know that hydrogen is green. Green hydrogen is the best hydrogen, maybe pink, debatable. There's gray and there's blue, and there's all these other kinds of ways that you can make hydrogen that are not good for the environment. And how do you know? If somebody tells you this is green hydrogen, how do you know that's where it came from? And so there's a humongous opportunity for nonprofits and entrepreneurs in this space to kind of go in and be that sort of check box to verify that this technology is really green, that this fuel is really sustainable, it really was produced in a clean way. So I would just encourage you all, if you're trying to figure out what you want to do with when you grow up, to look into environmental nonprofit work. It's really rewarding.
Absolutely. And maybe just on that, I'll mention one last thing. When you buy sustainable aviation fuel, it's not available at every airport. It's probably not available at Austin. It's probably available in Houston. And so there is a new platform that Shell launched called Aviation, which uses blockchain to do a balancing or an accounting of the aviation fuel so that an airline that's fueling in Austin can claim that it bought a percentage of its fuel as sustainable aviation fuel through a traceability software platform and through accounting and balancing of the fuel. If it comes out of airport X, but it was available in airport Y, then we can keep the balances that way. And we need that system because you won't have physical SAF available at every terminal at every airport. So
Does that software exist?
Yeah.
What's it called?
Avelia, A-V-E-L-I-A. We worked with Accenture and I think some other nonprofits. But you see that more and more, and it's similar to carbon credits where, your forest, that you're replanting is in Brazil, but your carbon credit is being claimed in Norway. That ability to globally, find a transparent and accountable way to allow people access to sustainable aviation fuel is also an area where there'll be more innovation.
So please raise your hands if you have a question. I will ask a question of Danielle. So you mentioned, I think, something like $15 to $30 a kilogram to deliver hydrogen, and maybe the previous panel on high velocity was talking single-digit dollars a kilogram as being feasible in a target. So can you explain how you get to 15 to 30? Like, is it compressed and in the plane and in a storage container and all this kind of thing? Why you say that kind of number?
I have friends that drive a Toyota Mirai in California, and I usually text them and be like, how much is a kilogram of hydrogen at the tank at the station today? So 15 is like gaseous at the tank, around, give or take, it fluctuates. But then the $30 price comes from liquefied hydrogen. So, I always say, like, it depends. Like, some people ask, when would you use gaseous versus liquid? If you were flying like a drone or driving a car, you could use gaseous hydrogen. But if you were flying like an air taxi or like what I like to call a giant drone or a flying car, which they do exist. I know Carrie told you I was going to talk about them. I forgot. They exist. I've been in them. I've flown in them. They're real. They're here. There's some companies in Texas working on them. You would probably want liquid. Anything bigger, anything that's a passenger aircraft and larger, even one passenger, up to 200, then you're going to want liquid hydrogen. Beyond a 200 passenger aircraft, like a twin aisle, that's not really the space that I'm in. SAF might be a better solution, just because you would need massive amounts of hydrogen. The volume would be so large. We might get there, but yeah, to answer your question, that's where my pricing came from, is just what it costs at the gas station. But the DOE, they do have the 111. So you might have heard that, like, there's a goal to get to $1 per kilogram in a decade. And I think it's like, now we have like 8 years or 9 years left now, because that goal was set a year or two ago. But there's a 111 target. If we got to that target, then yeah, hydrogen's going to be everywhere. We'll see ubiquitous use of it. Technically, it's possible to use hydrogen in aviation right now. Technically, we have the technology available. but it's the cost and that infrastructure transition that, and you know, like Monica said, that it would be on the passengers. You know, are we trying to pay, you know, $5,000 for a flight from, you know, Austin to Dallas? I don't think so. So kind of all those things kind of play into it.
Right. We'll go to Brian.
All right, really, really interesting. I've kind of a high-level question. So in terms of aviation fuels, sustainable aviation fuel, as you mentioned, is not exactly zero emissions. It's so you're lowering the carbon intensity of making the fuel, and then you have hydrogen. What are some different options people are thinking about in terms of a zero emissions fuel? There's hydrogen. Are there other options, or are we stuck on that?
Yeah, I didn't speak to e-fuels a lot, or synthetic fuels, but those are fuels that's a type of SAF where your feedstock is actually carbon dioxide waste. So if you have an emission point source of carbon dioxide that just can't be mitigated, whether it's a steel foundry or some sort of plant, you could take that CO2, combine it with green hydrogen, and use those building blocks to make your fuel. Those fuels have 0 to negative carbon intensity. So there are fuels that have 0 carbon intensity, for sure. Again, very nascent technology. There are some demos right here in Texas that are being built. So worth keeping an eye on companies like HIF and others, yeah.
Yeah, if I could just add to that, you know, hydrogen, and no disrespect intended whatsoever, but hydrogen is not nascent. Think about what's powered many space shuttles. We've been using liquid hydrogen in aerospace for decades, for almost 100 years. And so it's not, when I say it's technically feasible, it's very feasible. It's just, you know, NASA and space have a very big or infinite budget. If we had that, we'd be using it all the time. So, you know, we've got the technologies here. It's just a matter of some private capital taking a risk and maybe some government incentives that will really, you know, help us get off the ground. But again, you know, SAF and e-fuels, we see them, we as in HYSKY see them as a intermediary or transient fuel, as Monica said, to them, because they also use hydrogen, so that will help bring down the cost of hydrogen, and then eventually the ultimate goal would be that all of aviation goes to hydrogen.
I was curious if Shell is looking at nuclear, not so much with electricity, but with thermal in SAF production or hydrogen production for aviation fuels.
Not that I'm aware of, but I do know that we have a large projects and technology team that is has a broad number of projects. So in terms of what's near commerciality, no. But in terms of what's in the back room in the labs, I would like to take that question back and try to find you a more precise answer.
Hi, I'm Gail Height with the College of Engineering and Executive Education. But when you said hydrogen's been used for many, many years, I was saying, yeah, the Hindenburg, right? 1937, the blimp that blew up. So what is the flammability kind of component of hydrogen?
I have HYSKY has a shirt that we sell on our website, and it says, hydrogen did not cause the Hindenburg to blow up. It usually gets brought up at every conference. So we flew with hydrogen before the Hindenburg and after it. It's about as safe as any other fuel that we're used to using. What was so unique about what happened at the Hindenburg, and I have 2 books on this, not that I wrote, but other people wrote, about the propaganda that really went into that. Also, home video cameras, you know, people were just starting to have access, so it was caught on camera. But what caused that to blow up is the way they designed it. It was like caught and soaked in flammable fuels that they were storing it in. They flew into bad weather against engineers and people's advice. They flew into bad weather. They came into some lightning. That caused this big explosion. If you reproduced that event today with the way that we store hydrogen, you wouldn't have seen an event like that. So it's, you know, some qualities make hydrogen safer. It's much lighter than air. It's the lightest element. You know, if you remember on the periodic table, it's right there at the very top. so it disperses very quickly in the atmosphere. So that helps it not be as flammable. It doesn't pool in an area like other, gases and fuels do. It wouldn't be accurate for me to say that it's safer, but it's as safe as fuel that we put in our car.
Yeah. Hi, Dubem, first year MBA. Thank you so much for being here. So a question for Monica. So how would you say a company like Shell looks at investment? So investment in low carbon solutions and fossil fuel, given limited capex, and even within the low carbon solution space, how do they look at investment across portfolios? So US and Europe and all of that.
That's a great question, and I would direct you to the recent released Shell Energy Transition Update. It came out, I think, March 14th. And in there, this question is tackled head on, and it is really the messaging is around an energy transition with balance. Balance around the feasibility and return on the energy transition investments that we make, as well as energy security on the fossil energy that is still going to be needed for quite a while. And so the fundamentals around finance and investing do apply because the shareholders invested. So that assessment is made as to the risks and the likelihood of success on the projects that we take on. And the energy transition strategy outlines those projects. Shell is investing about a third of its annual capex for the next few years in this energy transition space, about $5 to $6 billion a year. We are definitely a leader in this space of low carbon solutions, and we are expected to lead. But is it enough is always the question. Are we doing enough is always the question. And what our CEO always struggles with is finding that right balance between doing enough and as well as delivering energy security and shareholder returns. So.
I've got a question. So years ago in the 2000s, there was a big thrust from the U.S. military about drop-in biofuels. And could you describe the progress that's been made in cost and scalability since then? I'm sure there's been some advancement there. And secondly, of the overarching SAF category, you mentioned e-fuels, I would imagine drop-in biofuels, but are there others under the SAF umbrella types of sustainable aviation fuels?
Let me think through the first question. For sure, the military is a great catalyzer of innovation because they'll take on the risk and fly this aircraft with expensive fuels. And the costs of SAF have definitely come down from the early days when the military was doing their testing. SAF, as I mentioned, is still expensive, so 2 to 4 times the cost of jet fuel. The cost is coming down because, again, of partnership with government. So things like the investment, the IRA, the recent act, has SAF incentives there at the federal level for people that invest capital in large SAF projects. Different municipalities and towns have regional SAF investments. For example, Minnesota has a local SAF incentives for airlines that are refueling at their airports. State of California has incentives. So costs have come down for sure compared to when the military was testing biofuels. Now, to your second question, I think we covered the major category types of SAF. So, the ready for commerciality SAF is taking fats and oils and greases, recycling those back in a refinery, hydrogenating them, and boom, now you have renewable diesel or you have a type of a SAF. That's easy to do, that's currently being done. I shouldn't say easy to do, that's well understood, and it's currently being done. The next generation is the area that I'm supporting within Shell, and that's the advanced biofuels that come from these sustainable feedstocks. Things like grasses, camelina, miscanthus, things like forestry biomass or sugarcane and corn, very exotic feedstocks with very nice low carbon footprint and definitely meet sustainability criteria. So we need to unlock those. The next gen is indeed e-fuels. We don't see e-fuels at scale yet because we need a lot of cheap renewable electricity to make that green hydrogen. and then combine that with CO2 point sources to make the e-fuels. Very difficult technology. So I think those are the major buckets. I don't think I'm leaving anything major out. So yeah, I would stick to those and say others are maybe less prevalent.
Thanks. I think we're 1 minute over. If you want to learn more about hydrogen aviation, go to HYSKY.org, HYSKY. And we're having a big hydrogen aviation event in Vegas in September. There will be flying cars there and all kinds of cool stuff.
Oh,
so
wow.
come talk to me after. Thanks so much.
All right. Thank you,
Thank you.
Danielle and Monica.